Good afternoon, everyone. Welcome back to Tech Talk Tuesday here at Treadwell. Edward Titley is my name. If you're joining us for the first time, welcome. And if you've joined us before, welcome back. Today we're having a look at our TreadSpec tool, which is our online specifying tool. What we'll do is give you a brief overview of what TreadSpec does, and then we'll run through our grating deflection calculator tool and also our grating flip selection tool. In the next webinar, which is in 2 weeks' time, we'll also just run through our structural calculation tool as well. So here in TreadSpec, we can view a library of the FRP structural sections. We can do deflection checks for horizontal beams. We can also do checks for vertical columns and the flat sheet as a uniformly distributed load or concentrated line load. We can do the same for the FRP grating, so span checks both with the UDL and the line load. We can use the fixing selector tool to help us select the right fixing for our application, and we can also access a step 5 library of all the FRP handrail components. So today we're looking at the grating deflection tool and the clip selection tool. With that in mind, we'll get straight into it. Just before we do, I've got the Q&A window open in front of me, so if you have a question, please put it in as you think of it. There's no need to wait to the end, and we'll attempt to answer it where we can, or we might need to take it on notice if we need to look something up and confirm for you. If we do, we'll ask you to send us an email, and we'll attend to that in due course. So we'll start off with the fixing selection tool. Try and make this a nice quick webinar for you. So today, we'll start off with the deflection calculator. So this is our grating deflection calculator tool. You can access TreadSpec here in the top right-hand corner of our website. With the grating product, or the grating deflection calculator, it'll allow us to select one of the 3 types of grating product we offer. So that is the Gratex molded FRP grating, the Moldtrex mold-truded FRP grating, and the Gridex pull-truded FRP grating. If you'd like to know more about those different types of product, what differentiates them, and why you should use one or the other, feel free to either reach out. We're not going to do that today, or if we've done previous webinars on it, you're welcome to view those on our YouTube channel or on our website under the Resource Center section here, videos. So we'll do 2 checks today. We'll do our molded FRP grading and we'll do our pull-truded FRP grading. So I'll try and keep it to commonly used products so it's useful information, but you're more than welcome to log on to TreadSpec at any time and do any checks you'd like to do. So we'll select a series molded FRP grating. We can select any of the molded grating products. We'll select our mini mesh product, and we'll select our 38mm thick mini mesh product. This will give us an isometric plan and an elevation view of the product. It'll also give us some details around that product. 23.5 kilos per square meter is the self weight of the product. P5 is the slip rating. This wheelchair symbol indicates it's compliant to AS 1428.1 and the DDA requirements. It's pet friendly due to the opening size, and various Australian standards here we're compliant to. Specifically, I'd like to note the 15mm dropped ball requirement, which is clause, I think it's 4.2 of AS 1657. I could be wrong on that clause number, so please don't hold me to that, but AS 1657 requires that 15mm drop ball doesn't pass through the FRP grating where there's a thoroughfare or a potential for persons to walk underneath that particular platform or structure. So we select our product. We can then perform a distributed load or a concentrated line load check. Distributed load's easy or pretty straightforward, I think, as a UDL. I'll just draw your attention to the line load at this point. Now, we often get asked what's the width of the sample that's line load tested. So as per Appendix A of the American Composite Manufacturers Association's grading manual, and you're able to download that online, it costs about $80 US. I would strongly suggest it's worth a read if you're looking to use FRP grading, or we're happy to run through it with you on a separate session to this. The sample size for the test for the line load is 305mm width, and then obviously at your various spans, and your load is applied in the center of the single span for the worst possible effect. So we can select a distributed load, say 2.5 kPa is a common one we'd get asked for. We can enter our span, say 800 millimeters, and it'll give us the resultant deflection mid-span, which is 2.37 mil, and span on deflection, which is L on 338. A couple of notes here in relation to loadings provided by, or where these loadings would come from. AS 1170 is commonly used. AS 1657 is often referenced as well for fixed platforms and walkways. And note that AS 1170 will provide us our serviceability limit, state, and load factors. The loads represented by this calculation are static load conditions at ambient temperature. Deflections for impact loads or dynamic loads will multiply the deflection by 2, and long-term loads will result in added deflection due to creep and will require higher safety factors, and these details are also provided in the ACMA or ANSI Grating Design Manual. Happy to share more details on those publications offline if you'd like to find out where you can download them. Once I've done this check, I can enter my email address and my name, and it will email me through this calculation as a PDF attachment. If I was to hypothetically put in a span that's not workable, say 2000 millimeters for this product, it'll come up in red here with a warning to let me know that this span is not suitable. Similar idea with the pultruded grating. We'll use another common product, which is our 38 mil thick, 15 mil wide load bar, 23 mil space between bars. Once again, we can see the self weight of the product. We can see it's got a P5 slip rating, and we can see isometric plan and elevation views of the product drawings, or what the product looks like. Same idea, distributed load or concentrated line load. The concentrated line load is done according to the same criteria. So the 305 millimeter wide section, load positioned at mid-span for worst possible effect. We enter once again, say a 2.5 kPa live load. If we're looking to design something to AS 1657, with a span of say 150 mil, and once again it'll come up with our mid-span deflection and span on deflection, and L on 390 as our span on deflection. Now, a couple of notes here around our limiting factors. When working with FRP, in the majority of cases, and this is obviously the majority of cases, it's general advice, it's not project specific. In the majority of cases, the limitation to FRP is deflection at SLS. So you'll note we're always talking about deflection when we're looking at both grating and also the structural sections when we look at those at the next webinar. We recommend for pedestrian comfort that mid-span deflection is kept to less than 5 mil, and that's from our research indicates that above 5 mil deflection, someone walking on the structure will start to feel some movement or the deflection underfoot, and that can lead to them not feeling confident or comfortable to use that structure. So that's where that comes from, and span on 250 is recommended as the max deflection from a product durability perspective. Now, that's not saying that the product is going to fail at a higher deflection. We would expect failure to be something around span on 40 or span on 50. So in some applications, greater deflections are acceptable as either a millimeter number or span on deflection of greater than span on 250, but we would typically like to discuss those on an application specific basis. So if you've got that application where, for example, some projects span on 100 is acceptable deflection, that's okay with FRP as well, provided the adequate attention is paid to both fixings and also the product from a creep or sag perspective. So that's the grating span calculator. This is our grating clip selector. So look, I'll only do one of these for time reasons, but I'm sure you're welcome to have a look at on your own time. And if there's any dramas, please drop us an email. Best email is hello@treadwellgroup, TREADWELL group.com.au, or you're welcome to give us a call, 1-800-246-800 for Australia, or call or email. Always happy to discuss if you're having any dramas with this, or you can jump on the web chat here and someone might be able to help you out. With our fixing selected, we'll keep with our Grating mini mesh just to keep it consistent. This is a 38mm thick product, 13mm clear opening, very commonly used. So how this fixing selector works is we select the support thickness of the material, say 10mm, and it uses that, it needs to know that so it can work out the appropriate length for the fastener. So this will distill down for you the fixings that will work with the grating you've chosen. So give us a few options: our mini M clip, which looks like this; our standard W clip, which is a disc style fixing. This one sits proud of the surface of the grating rather than dropping into one of the openings; or a slotted mini M clip, which looks like this. The reason for the slotted M clip is it gives us a bit more space internally for a larger fastener head, if that's necessary. Once again, happy to have a discussion around whether you need that slotted clip or whether you need just a regular mini M clip for your fastener choice. If we select the mini M, we can then select either a bottom clip if we want to clamp the product to the web of a UB or something like that, or we can select no clip if we want to screw or bolt directly to the structure. This will tell us the code for the clip and a product description, as well as the code for the grating we've selected, to tell us the fastener particulars. For example, M5 socket head cap screw gives us the minimum fastener length, and as I said before, it uses the thickness of the material to work that out. State a nut is required and a washer is required if we're bolting it. It doesn't do this yet, but we're also working on being able to modify the algorithm slightly to ask you your substrate material, so whether it's stainless steel, galvanized steel, timber, FRP, etc. And that'll allow it to further refine the most suitable fixing options for you. That's not quite ready yet, so in the meantime, once again, you're welcome to reach out, give us a call, or drop us an email, and we'd be happy to discuss that application with you. If we select an underside clip, and this is what we call a J clip, and that'll allow the product to clamp, as I said, to the flange or the web, the flange, I should say, of a UB or UC or channel, and this once again gives us an updated diagram. I can also email this to myself, name and email address, and it'll send that as a PDF. And lastly, if we select a different top clip, for example, the W clip, you'll note there's some different options that come up here. And that's because the W clip has a different size fixing in it to the M clip we looked at, the mini mesh M clip. That means some underside clamp options or some different options are available to us. Once again, we've got our product codes: top clip, underside clip. You'll note our fastest gone to an M8 hex head set screw, 65mm length required. And you'll also note that a nut is no longer required and a washer is no longer required. And the reason for that is the H clip has a thread tapped into it already, so there's no need to use that. There's no need for a nut or a washer. Hope that all makes sense. Hope it wasn't too fast for you. If you'd like to watch it again, just drop us a note, hello@treadwellgroup.com.au. We'll be able to share the recording link with you. Or if you'd like some help on a particular project, once again, drop us a note, hello@treadwellgroup.com.au. Team would be more than happy to assist. And I'll stay on for a couple of minutes now. If any questions come up, please feel free to drop them on the chat or the Q&A on your Zoom meeting. And last thing I should add, there's also a poll that should have gone out just with a couple of questions for you. It'd be much appreciated if you could answer those around content you'd like us to cover in the future and so on. And lastly, always welcome any feedback, good, bad, or ugly. If the webinar was a waste of time, it was boring, please say so. If it was worthwhile, please say that as well. And if there's something you'd like us to cover, feel free to do that as well. As I said, we'll stay on for a couple of minutes. Otherwise, we'll see you in 2 weeks' time. Question in regards to the US grading manual. Hope you can see my screen. I'll just try and bring it up for you. It's called the ACMA/FGMC grading manual. The document number is FG01-17. If you just Google the ACMA grading manual or the ANSI grading manual, you should be able to find that document for download. Sorry, my license doesn't allow me to share it with you, but you are absolutely at liberty to download it. And I'd suggest said to anyone who's looking to be specifying the product or working with the product, in a reasonable quantity or on a reasonable size project would be worth having a look. $145 where we are here, and thank you to those who just thanks whoever just commented it was insightful. Glad it was worthwhile for you. Thanks for attending. Stay on for another minute. It's 1:46 p.m. here in New South Wales where I am. Stay on to 1:47. Any other questions, please feel free to put them on the chat. And if you think of something afterwards, always welcome to drop us a note. hello@treadwellgroup.com.au. That's TREADWELL group, all one word, .com.au. And one of the team, myself or one of the team, will be very happy to answer that for you. Thanks, Praveen. Glad it was worthwhile. Jeff, on your question, traditionally the components are 316 stainless. Yes, some components we stock in galvanized steel. If some we stock in gal, other products we're able to make in gal if there's a dissimilar metals issue or something like that. And there's obviously ways and means for clamping or if you're bolting through a structure. And I think I'm aware of the project you're asking this in regards to ways to isolate the stainless fixings from a mild steel or aluminium structure to prevent dissimilar metal contact. But typically they're stainless. In direct answer to your question, yes, 316. We have from time to time done duplexes and super duplexes, 2205, 2506 as needed, and obviously we can manufacture the items in galvanized steel as well if that's preferable. Looks like that's about it. Once again, thanks for joining. Appreciate your support. See you again in 2 weeks, and we'll be looking at the deflection calculator for our architect structural sections. Keep an eye out for the link to register either by email or on LinkedIn. And once again, any questions, drop us a note, hello@treadwellgroup.com.au. Be more than happy to try and help out how we can. Thank you once again for joining. Have a good rest of the day. Cheers.